All right. And okay, so now I'm ready to actually start implementing the dynamic array insert. And in order to do this, I'm going to share my screen so that we can look at NetBeans. And here's what I have done. I have gotten my Arraylist class. This is the Arraylist class that I gave you, put it up on Moodle, the one that I've been working on earlier this week and late last week. And I copied it and I pasted it into a new class called My Arraylist Dynamic. And notice it's the same code all the way down. So mostly dynamic arrays and static arrays work the same, mostly. But I'm going to make a couple of very important changes. First, my capacity will now no longer be public final, right? It will be private, all right? And I don't necessarily want to use the word capacity, all right? What I'm going to use is a technical term called buffer size, okay? I'm going to pretend that the empty space in my array is kind of a buffer. A buffer is a term that's used in computer science for a thing that stores data. Now, usually it stores it temporarily, okay? So, hence the term like buffering, but I'm just going to co-opt that term and I'm going to call my thing here buffer size. And this is how many spaces my array list is going to start out as. And every time it fills up, this is how much space I'm going to add on to the end. Now, I'm going to use the array's length to tell me how big the array is. I don't need the capacity anymore. I can fake it by getting the array's size because that's going to be growing as we do this. And I'm going to start with a really small one. I'm just going to say 10. All right. And this is going to allow me to increase it more easily. And so my array is going to start out with buffer size, right? Some linked lists allow you to actually set the buffer size. I'm sorry, I said linked lists. Some dynamic array lists allow you to set this how much you grow size, and some of them allow you to set it to 0, which is sort of interesting. But anyway, we're going to start with R at buffer size, and I'm going to go down and is full, right? If size equals, and then in this case, I'm going to do R dot length because that will tell me if it's actually full. And so that's very critical in this situation to get this right. I'm trying to think if I'm doing anything else, and there's not. And so now what I have is a situation where my buffer size is 10. My array starts out at that size. My positions, when I insert, these are still predicated on size. Remember, size is how much is in the list, and that's still the critical part of the array-based list. But the thing is, if the list is full, now I don't want to just say we're done. So instead, what I want to do is, if the position is bad, then I want to bail. But if it's not, okay, then I want to do something else. So if the, oh, well, that's my link. I thought I had copied that, but I didn't. So if is full, right? If that's true, then I want to return true because I'm going to be able to insert, assuming I have enough RAM. And if I don't have enough RAM, it'll crash for other reasons, and I'm not really concerned with us dealing with that. But then what I want to do is insert, and I've got to come up with the name of it, insert expanding the list. It's kind of a dumb name, but whatever. And what I want, still, I need the value and I need the position. At this point, though, I know for a fact that position is valid because I've already validated it. The thing that I don't have is enough room. So let's copy this name. And actually, silly me, that's a parameter list. So I will copy this and I will get rid of that and get rid of that and make it an argument list. Remember, don't put types in parameter lists. How dopey was that? Anyway, so here I have my insert expanded. This is going to be, actually, I'm going to make it private. I don't want anybody calling it. And I'm just going to make it void. It's just always going to work. At least that's my assumption. Right? And now I've got to decide exactly how to solve this. Well, I've already said what I have to do in terms of the steps, but let me jot them up here, right? I need to make a bigger list. Okay, I can write sometimes. And I should say make a bigger array, right? And then I need to copy until I get to position, and I decided to put 2 L's on until. Copy until position, right? Then I need to insert at position. And then I need to copy after position. And then I need to increment size. So I know this is where my head is, but I just wanted to jot it down so that we would have this to refer to. Okay, and I forgot to screen share. I'm going to have to get better at that. So let me stop the share so I can show that. Make a bigger array, copy until position, insert at position, copy after position, size plus plus. So that's the idea of what we're doing. Okay, so let's share it up again. All right. Questions so far? You guys know what we're doing at least. All right. So now I'm going to start writing this, and we're going to make sure that it works, right? But the first thing that I need to do is I need to create a new array of the same type as my storage array. So I'm going to declare an int r. I'm going to call it an int array, and I'm going to call it temp r, and I'm going to set it equal to a new int array, and this int array is going to be of size r.length plus buffer size. So now it's going to be bigger. So my array that started at 10 is now going to have 20. And now I've got to copy until I get to position. Right? And this is just a for loop. So I start at 0. Okay, I've got my new array. I want to just put the new array over there. So I'm going to go, so I is equal to 0. So long as I is less than position, that means all the things above position, right? What do I do? Temp r at I equals R at I. And I can get this spelled right, R at I. And so that does that. Now I can set temp R at position, because I just reached position, and I can set that equal to value, which is what I want to insert. And now I need to get the things that are below. I need to make sure that I'm not doing it into my old array, but into my new array. And now here's the tricky part. We've done all this so far and it's fine. So let me draw a little bit here. We've got our new array, and it's bigger and thinner, right? And we copied everything over until we got to position. And then at position, we put in our new item. Let's put a 4, right? So we've got 2, 8, 10, and that's our new item. Well, now we're going to be at position over here, but we're going to be offset by 1. 1, 0, 1, 2, 3, and then we have 4, 5, 6, 7, 8, 9, 10. We have 1 extra, whatever. So note that the 0 goes into 0, 1 goes into 1, 2 goes into 2. As we go down, approaching position, we just dump the things over. But once we put the item into position, everything in this array is shifted down 1. So we're going to start at position +1, right? And we're going to get the element that's there -1 over here. So this one's going to get that one, and it's going to be offset. So the 3 is going to go into 4, the 4 is going to go into 5, the 5 is going to go into 6, all the way down. And we have to make sure that we stop at the right spot. Once we've grabbed this 5, once we get to our current size, we will stop. And that will have copied everything over. So now let me get the share back up. All right. Now we need to copy all below position. Well, and equal. All right, so this is another for loop. In this case, though, I want my I, right? I want it to be set equal to position +1. This is what I'm getting from my new array. It's the position that I want to set in the new array. And temp R at I now equals temp R at I -1. So 1 back. And I want this to go so long as I am less than size, and I actually want to do this when I am equal to size, because I haven't incremented size yet. And then I will decrement size. And then I'll be done. And the item will be put in place at the right spot. I'll come back here, return true, and this should be good. Of course, it should be good. Now let's test it and see all the ways that I did it wrong, because that's the way it works. So I'll do a my array list dynamic. Create a new one. All right. And now I'll insert, but in this case, I'm going to insert, let's insert 34 things, right? we'll just insert a bunch of them. And when we print the list, right, well, let's just see if it works. And I don't want to do insert at, or yeah, I just want to keep doing insert at, but I want to worry about whether the array is full or not. When the array gets full, it should fill up. So now that I've said all this, I'm starting to think about it, and I'm thinking of all the things that could possibly go wrong. But let's go ahead and dive in and fix those as we find them, knowing that it's highly probable that something will go wrong. It inserted them and then quit because I did something terrifically wrong. And right when that happened, I realized what I did. In my insert expanding the list, I filled temp array with the values, first of all, from itself, which is stupid. Okay. And then, because I needed to copy them from here into there, that's strike one. Now let's go for strike two. I didn't set R equal to the new array. So I didn't even use the new array. How dumb is that? So R is a reference. Remember that. Because it's a reference, I can point it at any array object. So I have this old array object that wasn't big enough, and I have my new array object, and temp R knows where that is. So I can set R equal to temp R, and now they're both looking at this new list, or this new array, and the old array is no longer referenced. Objects that are not referenced are marked for garbage collection, so it will get thrown away at the appropriate time, the next time the garbage collection decides to activate. All right, so I ran it and it went wrong. And so I was sitting there thinking it didn't feel right. And when I run code for the first time, it almost never feels right. And it went wrong again. Let's see what the hell went wrong this time. R equals temp R. I don't know why it went wrong that time. So this is what I'm going to do. I'm going to pause the recording, and we'll figure it out live, and then I'll explain it. So pausing now. Okay, I'm unpaused, and I found my error. It is hilariously stupid. I subtracted one from size. Okay, if you saw that and were screaming into your headsets or whatever, why did he do size minus minus? The answer is I just completely typed the wrong thing. And so programmers do that. And so now let's run this, and we'll notice that it expands its size. One thing that we can also do right here is I'll S out the list's size. So my R list dot get size, right? One thing that I did not do is a get capacity, but let's at least do this, and let's close this one down because this one's going to stay running if I don't shut it down. And it says 34, which is what you would expect because that's how many items I put in it. When it comes to its capacity, the capacity ought to be 30. So let's go to the dynamic array based list here. And I did not make a method for its capacity. So let's just do that right quick. There's no real reason why people can't know.
Sorry, you're not sharing your screen.
I'm sorry?
You're not sharing your screen.
Aha. Thanks for telling me that. I wasn't sharing my screen. That's why I need you. Thanks for vocalizing that. So I'm getting the capacity here. This is just return r dot length, right? Okay, thanks for that catch, nice catch. Once again, my level of experience at this is low. And so let's go back to the driver where I added a print the get size. Now let's do this dot get capacity. And once again, I can get this capacity by using a getter. This just reinforces the idea of encapsulation. Although I can get the size and although I can get the capacity, I can't set them because they're automatically updated as the list grows and shrinks. So anyway, let's run this again and see. Hopefully by the 34, there will be a larger number than 34. Hopefully it will be 40, okay? And so as we increase the size, our capacity grew, and it inserted in what looks to be a correct way. One thing that we can do sort of in a fun visual, we can insert here, and we can see it the whole time. This is going to be a whole lot of inserts. It's going to be a whole lot of text showing up, but let's run it and see what it looks like anyway. Let's go to the top. So we've inserted. We have one item and our capacity is 10. We have two, capacity is 10, 3, 10, 4, 10, 5. We keep going, we get to 9, 10, we get 10, 10. It's full, no big deal. Then when we insert, we are full right here. When we insert, we put the 11th item in. Our capacity just doubled, and we put the item in. And so then when we get to 20, we're full. We want to put this new number, it looks like a 53 on the end, right? When that happens, our size went up by 1, but our capacity went up by 10. And so every time this occurs, every time our size and our capacity are equal, then our buffer size, then we increase our size, and this happens one last time. Where is it? Right here, and our capacity goes up to 40, and we can just keep doing this. We could use bigger numbers if we wanted to, and in fact that is a smart thing to do. Typically the capacity of these starts at some smallish number, 100, 1,000, 500, something that's not tremendously large, but is probably useful for a lot of smaller operations. And then as it fills up, it expands, usually at a pretty big rate. Very often, in fact, array lists will double in size or grow by 50%. Like they'll actually do a little math and grow by a percentage every time. So sometimes they can gobble up a lot of RAM as they grow. But there's usually on modern systems a lot of RAM to gobble up. So that's generally okay. One of the weaknesses of having a small buffer size is that you have to do the operation of making a new array a lot. One last thing, I didn't talk about this, but it's how to make the array list smaller. Here's kind of a weird fact, is that's not done a lot. One of the reasons that it's not done a lot is because if a program needs RAM, if an array needs RAM, it will probably still need it, right? If your array grows to size 400,000, it did so for a reason. So even if the array nearly empties, it's not always wise to throw away your big capacity array because you use that capacity at one time and you don't know what the program is going to do. It might fill up. So although we could reduce the size, I'm not really going to bother with that. I'm going to do one little trick, or I'll talk about it. One thing that you can do is this. Let me start my screen share again. One little thing that I do have is get list as array. What this does is it creates a new integer array, but it creates it at exactly the size of the list. So it throws away any extra buffering, any extra capacity. It copies the list into that new array and returns where that new array is. So if I wanted to, I could modify the get list as array and make it something that's the current size, maybe plus 1 buffer, right? So if my array list was 400,000 and now it has like 150, and I wanted to reduce the size, I could do that, and I could make it exactly full, like this one, or I could make it so that it just went down and then had the buffer as well. So anyway, that's the topic list for today. Let me